Hello everyone, welcome to the class on Medicinal Chemistry Strategies for GPAT. In this video lecture, I am going to cover these strategies. The strategies are applying retrosynthesis to understand how a drug molecule is synthesized, understanding structural activity relationship and how you need to apply the techniques to answer a question, identifying major groups in drug molecules and how it helps you to get correct answers in medicinal chemistry questions. Similarly, observing heterocycles. Okay, let us begin. Now, this question is asked in GPAT 2018. Identify the starting material A and B in the synthesis of clomiphene. Clomiphene is used to enhance ovulation in women and it is also used to treat polycystic ovary disease in women. Now, see, the question has given the entire synthesis except the starting material A and B. The combination of A and B results in this compound, and by using these reagents, look at this reagent. This is a Grignard reagent, RMGX. R is benzyl group here. Now, by using this reagent, this group attachment has occurred, and by using N-chlorosuccinimide, clomiphene results. Now, what we need to do is, we need to identify what all these starting materials are. Let us understand the question. Now, there is a synthesis process called as retrosynthesis. Now, the question asks about what are A and B. Now, you need to synthesize this compound. Now, retrosynthesis means you need to observe what you have to synthesize, that means the final product, and then look backwards about the starting materials. That means looking at this product, you need to think how can you make this compound by using this starting material. Because you are going backwards, this method is known as retrosynthesis. Now let us understand this compound. Now see, this thing is benzophenone. Benzophenone. So this is what is there, benzophenone. And look at this one. What is this? Diethyl. Two ethyl groups are there and amino group. Diethyl amino ethyl. So you have two groups are there. This one at one side you have diethyl amino ethyl is there, right? And this side benzophenone is there. Look at this. This is what is benzophenone is there. Now your job is you need to connect with an oxygen bridge. How can you do that? Think about it. If you take 4-hydroxybenzophenone, now because oxygen is more electronegative, losing hydrogen will be always easier. When you lose hydrogen as proton, what happens? You generate a negative charge here. Now you need to combine this carbon with this negatively charged oxygen. Now understand this logic, always think about this. In organic chemistry, an electrophile always reacts with a nucleophile. What is electrophile? Which has got a positive charge and it loves to go towards electrons, that means a negative charge. Now what is nucleophile? It has got a negative charge and it always goes towards a positive charge. So always there is a bond between an electrophile and a nucleophile. Now look at this. What is this? This has got a negative charge. That means it is an nucleophile. It goes towards positive charge. Now what you need to make? If you can create a positive charge on the carbon, the bond formation will become easier. Now what is the easiest way to make a positive charge on carbon? By attaching a halogen. Imagine if you have a chloride. Chloride is an electron withdrawing group. It comes out with Cl minus. It is pulling out the electrons and it generates a positive charge on the carbon. That's it. This is what you need to understand. Let me explain it again. See, by using retrosynthesis approach, you need to see what is the final product is. Here the final product has got two fragments, a benzophenone fragment and the other one is diethyl amino ethyl group. Now you need to form a bond. This bond is crucial, right? That oxygen, that either bond you need to form. How can you do it? By taking a hydroxy group here and by taking a halogen halide derivative here, you can create a carbocation here and oxygen with a negative charge and a bond formation occurs. So these are starting materials. I hope you understand this. This is a very important technique. It is called as retrosynthesis. You don't need to learn the entire synthesis. Understand how can you generate the charges. Remember this concept. Always there is a reaction between an electrophile and nucleophile. Organic chemistry revolves around this. Now look at the options. What is the first option? 4-hydroxybenzophenone and 2-diethylamino ethyl chloride. What did we do here? This is what is 4-hydroxy. This is 1, 2, 3. At fourth position hydroxy is there, and this one is diethylamino ethyl chloride. Bingo, this is the answer. So my dear students, you need to understand how these concepts are applied. How these concepts are applied. So if you understand retrosynthesis, any synthesis you can do it, and understand these things. In GPAT, you are not supposed to write the entire synthesis of a compound. No, they will be giving options and you need to find out the correct answer. In order to do that, you need to develop skills. You need to understand mechanism. I hope this is helpful. Moving further, now the next major thing is identifying major groups. In any medicinal chemistry molecule, drug molecule, you need to identify what all the major groups it have. You don't need to learn the entire structure, but observing or identifying the major groups will help you a lot. Look at this question. Now, this question is given in GPAT 2019. Now, the following ACE inhibitor used in treating cardiovascular disorder is synthesized from natural amino acids L-alanine and proline. Which is that? Now, what is the question asks about? In order to be specific, the following ACE inhibitor contains alanine and proline, and you need to find out which drug is that. Now, some of the ACE inhibitors, they all have proline. But let us observe the answers. So, the answers given are enalapril, captopril, lisinopril, ramipril. Again, my dear students, understand the drug names are given with a particular purpose. All of them ends with pril. All prils are ACE inhibitors. In case of antibiotics like penicillins, they all end with silins. In case of beta blockers, they all end with OL and OL. Right, now let us see this. See, the reason why enalapril is known as enalapril, Ela is an amino acid alanine and it contains proline. So, enalapril is made up of alanine and proline. Now, whereas captopril, capto is derived from mercapto. Mercapto means thiol group. Thiol group plus proline. So, next one, lisinopril. Lysine is derived from lysine. Lysine amino acid plus proline. Ramipril, again, it has got amino acid alanine, but it doesn't contain proline. So, this is how the names are derived. Now, what is the question about? The question is asking about you need to find out a ACE inhibitor which contains alanine and proline. What is that alanine and proline containing one? It is enalapril. So, this is how you need to learn the structures. You don't need to understand and learn each and every atom of the drug. No, you need to observe the drug and identify what are the major groups. Like, see, amino acids are always helpful. Most of the drugs contain amino acids and you need to identify them. Look at the structures. See, captopril, as I told you, it has got a mercapto. Mercapto. So, from this capto, you have got this name. Now, enalapril, look at this. This part is alanine. See, this is a carbon and this one is a methyl group. So, this is what is alanine is. Now, look at this lisinopril. So, this fragment is lysine. All of them are amino acid. Lysine is a basic amino acid. Now, ramipril, again ramipril has got alanine here, but there is no proline. See, this one is proline. This one is proline. This one is proline ring. Now, understand, whenever you read, whenever you try to understand the structures, you need to think like this. You need to identify what all the groups are, what kind of amino acids it has got. That is enough. Look at this question. This is asked in 2019. The question is about, they are not asking you to write the complete drug structure. They are just asking, these amino acids are found in which drug. So, this is how you need to learn. So, that's why identifying major groups in structures is very important. We'll see with another example. See, this is again asked in 2019. Now, look at this. The semi-synthetic derivative of penicillin is synthesized by acylation of 6-amino penicillinic acid with para-hydroxyphenylglycine. Which is that one? Again, see, they have given particular groups in a drug and you need to identify what is that particular penicillin is. Now, what is this para-hydroxyphenylglycine? Para hydroxyphenyl means at fourth position hydroxy group is there, right? This is phenyl. Now, what is glycine? Glycine is the simplest amino acid. So, this is what is glycine is, right? So, this group combined with 6 amino penicillanic acid gives 6 amino penicillanic acid gives a particular penicillin, and we need to find out what is that. Now, understand again this. See, the names are given with a specific purpose. All penicillins which starts with A, they contain amine group. That is the reason why amino penicillins are given A starting alphabet. Whereas C1, they are all carboxy containing penicillins. That is the reason why they will start with C. Now see, becampicillin, again it is an ampicillin derivative. In fact, it is an ester of ampicillin. Now among this you need to find out which one contains this group. See, ampicillin, amoxicillin, both of them are amine containing one. But O comes because para-hydroxy is there. Again, see the logic. Excuse me. The name is given according to the structure. So amoxicillin has got this structure. You can see the structure. So this is what is amoxicillin, and this is what is glycine group is, and this is para-hydroxyphenyl group. For your knowledge and information, see this part, see this remaining part is known as 6 amino penicillanic acid. The numbering starts from here 1, 2, 3, 4, 5 and 6. So at 6th position you have amine group is there, hence it is known as 6 amino penicillanic acid. Now leaving that thing, understand one more important thing. See, this 6 amino penicillanic acid is made up of 2 amino acids. Look at them. Look at this part. This part is known as valine. See, this is an isopropyl group and this is a carbon with carboxy group and amine. This is valine. Now the remaining part, this one is also an amino acid. This is cysteine. So thiol containing cysteine. So in fact 6 amino penicillanic acid is nothing but valine cysteine. So this is made up of 2 amino acids, and to that again one more amino acid is attached. So this is how penicillins are made. And 6 amino penicillanic acid you can get it naturally, and the remaining group is attached, hence it is known as a semi-synthetic derivative. So is it clear? Now again let me repeat this. So amino group containing penicillin starts with A, carboxy containing starts with C, ampicillin derivative becampicillin, ester. So the answer is amoxicillin, which contains that hydroxy group. See, now understand the importance of learning amino acids. I would suggest we have 20 amino acids are there. It is always better to learn all the 20 amino acids. It is very easy to learn. For example, see, as I told you, the simplest amino acid is this one. This is glycine. Glycine is the one which do not have asymmetric carbon. Leaving this, all the amino acid has got asymmetric carbon. Now, in this glycine, if this hydrogen is replaced with methyl group, it becomes alanine. Just you add methyl, you will get alanine. Now, again, in this glycine, if you replace a hydrogen with phenyl group, you will get phenylalanine. So learning amino acids is always advantage. So I would suggest you to learn all the 20 amino acids. Now moving further, the next one, see again, the following important sterol in feces formed from cholesterol by bacteria in lower intestine, and you need to find out what is that particular sterol is. Now look at them. 7 alpha hydroxy cholesterol, coprostanol, 7 dehydrocholesterol, lithocholic acid. Now by looking at them you can see these two are, both of them are cholesterol derivatives. Now lithocholic acid, cholic means bile. So this is from bile, litho means stone. So see, this is a bile acid which is responsible for stone forming, hence it has got the name lithocholic acid. Now let us understand the other thing. Coprostanol, copro means feces. Now what is the question about? Which one is formed in the feces? If you understand this word, you will get the answer. Without knowing anything, you can just get the answer. That is the reason why I made a previous video about understanding words. You understand the word, you will get that. But let us look in detail. Now what do you mean by stenol? We have sterols and we have stenols. What is the difference? In sterols, you have a double bond. Unsaturation is there. In stenol, it is completely saturated. In fact, what happens is the cholesterol is reduced or hydrogenated by gut bacteria to coprostenol. The reason why this is important is this is a marker. The presence of coprostenol indicates the presence of human feces in a particular area. So this is the significance, but the important thing is the moment you know this word copra, you will get the answer. These are the structures. See, cholesterol, we know this is how. Coprostenol, see the difference. This double bond reduced to this one. So this is called as coprostenol. Moving further. Now, the next strategy is understanding SAR, structure activity relationship. You need to understand them logically, not reading by hearting point wise. You need to understand logically. What do you mean by logical? Understand this question. See, this question is again asked in GPAT 2019. See, which of the following second generation beta 1 blocker contains 1,2,5-thiazole ring in the structure? Now let us understand. See, you're talking about beta 1 blockers. Now according to SAR, all beta 1 blockers has got a pharmacophore. Pharmacophore means the group responsible for its mechanism of action. What is that pharmacophore? In case of beta 1 blocker, it is aryl oxypropanol aryl oxy 2-propanol amine. See, aryl is a generic word. I just gave this a phenyl ring, but this is what they say. They need to contain an aryl ring, oxy, 2-propanol and amine. This particular pharmacophore, this group of atoms must be there in order to show beta 1 activity. So this is what is one of the SAR requirement. But you can have heterocyclic rings. Certain exceptions are there. There is a drug which do not contain this. It is just a aryl ethyl. It contains just aryl ethyl group, but still it shows beta 1 activity. So while reading SAR in a class of drugs, you need to identify these things. The exception is sotalol. So sotalol is not exactly this thing. It is not aryl oxypropanol, but it also has got beta 1 blocking ability. Now penbutalol, pindolol. See, both of them again, buta indicates to this amine there is a isobutyl chain is attached. That is the reason why it is called as buta. For pen also it has a name. The reason why it has got pen is it has cyclopentane ring. Now pindolol, it contains the aryl ring as indole. But what is the question? You need something called as 1,2,5-thiazole. Now look at this. Timolol, T, thiazole, morpholin. Both the rings are there, hence it is known as timolol. Again, sotalol, sulfonamide derivative. That is the reason why it is called as sotalol. Look at them, identify these things. By understanding the name and the structural relevance, you can learn all the drug structures. Look at the structures. See, penbutalol, cyclopentane, pen. Here, butyl, isobutyl butalol. Again, pindolol, what is this ring? Indole. Timolol, what is this? 1,2,5-thiazole, and this one is morpholin ring. T, thiazole, morpholin ring. All of them ends with OL. Now sotalol, look at this, sulfonamide group. This is the only exception. It is not aryl oxy, it is aryl ethylamine derivative. So this is how you need to understand the groups and then learn medicinal chemistry. So what is the answer for this? The answer is timolol. This is asked in GPAT 2019. Moving further. Now see, this is my favorite one. See, this 4-aminoquinoline anti-malarial drug has 2 trifluoromethyl moieties at position 2 and 8 and no electronegative substituent either at 6 or 7 positions. See, the entire thing, what are they talking about? The following group is an anti-malarial drugs. Now in that you need to find out a drug which has got this moiety, 2 fluoromethyls, but 2 fluoromethyls at 2 and 8 positions. It should not contain any electronegative substituent at 6 and 7. So these are SAR points. Now, but before knowing anything about the drug or structures, you can answer this question. What is the key point here? It has to have 2 fluoromethyl groups. See, again understand the drug words. Mefloquine. Why it is called as mefloquine? Meflo means methyl fluoro. What is the question about? They are asking about trifluoromethyl. That is what is here. Chloroquine, chloro derivative is there. Primaquine, primary amine is there. Amodiaquine, amine group is there. See, you can see every name indicates a particular group. If you see the structure, this is what is there. See, this is second position. What does it say? 2 and 8. At 8th position, you have another trifluoromethyl group is there. At second position, you have another trifluoromethyl group is there. Right? At 6 and 7, no substitution is there. So this is what is the question about. I have explained this in detail in another video, but still I am talking about this because see the importance. Even if you don't know anything about the structure, by understanding these words you can answer. So this is what is the strategy is. Now moving further, now observing heterocycles. Now see, our drugs always contains heterocycles, and instead of learning atom by atom, you need to observe what is that particular heterocycle is. Again, see the same year in GPAT 2019, similar kind of question is asked. See, the basic ring system present in antihypertensive and antiglaucoma timolol. So I explained you already, timolol. T indicates thiodiazole, MO indicates morpholin ring. So morpholin is there and thiodiazole is there. But see, it has given all kind of, see this one is thiazole, this is not. It has given all kind of thiodiazole. But what is the thiodiazole you have? 1,2,5 thiodiazole. Look at this ring. See, azole means a 5-membered heterocyclic ring. Diazole means 2 nitrogens are there. Thiodiazole means 1 sulfur, 2 nitrogens are there. 1,2,5 means sulfur is given priority. So this is 1, 2, 3, 4, 5. So 1,2,5 thiodiazole means at first position sulfur is there, at 2 and 5 diazole is there. So this is the answer. The numbering is 1, 2, 5. Again, you need to understand the heterocyclic rings. Instead of learning each and every part, you need to identify the SAR, you need to identify the important functional groups, you need to identify what is the heterocyclic ring is. Done. You don't need to learn the entire structure. Now, see one more question. See the heterocyclic nucleus present in nitrofurantine. See R, there are 2 rings are there, that is the reason why they are using R. Nitrofurantine, the name itself indicates it has got a nitro group. So nitrofuran, imidazole, nitrofuran, imidazole, nitrofuran, imidazole. This is furan. No, this is not correct. Nitro is not there. For such kind of questions, you need to understand the structure. Again, you need to identify heterocyclic rings. What is this ring? Oxazole at second position. I'm sorry. This is a furan ring. This is a furan ring. At second position, you have nitro group is there. See, you need to talk about heterocyclic rings individually. If you take this ring individually, this one will be 1. At second position, you have nitro group is there. So 2 nitro substitution is there. Look at this. 2 nitro furan is there. And what is the other one? Imidazole 2-on. See, this is imidazole, 5-membered ring with 2 nitrogens at 1,3 position. 2,4,1. This is 1, 2, 3, 4. So imidazole 2, 4. I'm sorry, this one is imidazole 2,4-dione. Now look at this. See, 2-nitrofuran is present in both 2 and 4 options, but imidazole has got dione. So this is the right answer. So instead of learning the entire thing, you need to identify what all the heterocyclic rings are present. Now, again, this one is asked in GPAT 2020. See, again, riboflavin chemically is, again, the question is about what do you have chemically? Now see, this is what is riboflavin is. See, it is a little bit of complex structure, but you need to know what all the things are there. See, this ring is known as isoalloxazine ring, and then this 5-carbon ring is known as ribitol chain. In fact, riboflavin is a B vitamin. Its coenzyme form is flavin mononucleotide and flavin adenine dinucleotide. Now the question is, what is chemically, what does it has got? Now see, isoalloxazine ring is present in everywhere, but you need to find out whether it is dimethyl or diethyl. It is in fact dimethyl. See, only methyl groups are there. Where do you have? At 7 and 8 positions are there. See, in the examination they have given 8 and 9, but it has to be 7 and 8 dimethyl isoalloxazine. So again, see, the question is only about what kind of ring you have, what are the substituents you have. That is what is important. Now moving further. Now, antifungal agent 5-fluorocytosine is converted to its active metabolite 5-fluorouracil by one of the following fungal enzyme. So this is very simple when you know this heterocyclic nitrogen bases. You know, cytosine, uracil, both of them are pyrimidine derivatives. Now in cytosine you have an amine group is there, and this is how it looks. So this is what is cytosine is. Now what is uracil? Uracil is also a pyrimidine derivative, but what is difference? Instead of amine you have oxo group is there. So this is what is there. Now the question says, see 5-fluorocytosine, that means at 5th position fluorine is there, is converted to 5-fluorouracil. Now what is the enzyme required? So for this conversion what do you need? What is the change? Amine is removed, and instead of that you have an oxo group is there. Cytosine deacetylase, no, you are not removing acetyl group. Cytosine reductase, no, you are not introducing hydrogens. Cytosine demethylase, no, you are not removing methyl group. What are you doing? Cytosine deaminase, removal of amine. So how do you get this answer? When you know these basic rings. So this is what is depicted here. See, cytosine deaminase. So my dear students, in order to get command over medicinal chemistry, you need to understand what is the particular group present, what is the heterocyclic ring present, and you need to combine this with structure-activity relationship. In order to understand synthesis, you need to understand how do you go with retrosynthesis. If you understand organic chemistry, retrosynthesis will become very easier. Hope this video is useful. Thank you for watching this video.